Good day, I'm Gregory, and welcome to my second Calculus end-of-year assignment. Today we'll be talking about Chapter 22, Review Set 22B, Question 4. Things and items that you need to know before that is like integral and antiderivation, which is like finding maybe displacement from velocity. Anyways, let's start. A boat traveling in a straight line has its engine turned off at time t equals 0. Its velocity at t seconds thereafter is given by t equals 100 over t plus 2 bracket square meters per second. The first question is the initial velocity of boat and the velocity after 3 seconds. Initial velocity, as mentioned at my last assignment, is when t, or like the x value, is equals to 0. Hence, you can we'll set t to 0 when t equals 0. It's a very easy equation, so you just have to divided by 4 because of square, you get 25 meters per second. If you're doing IB, don't forget to add in your units because it might affect your marks. Secondly, finding the velocity after 3 seconds. As simple as it is, just input 3 into the function, and then you'll find 4 meters per second. Now, to question 4b, describe the function velocity t as t approaches infinity. Without even graphing this graph, you can see that there's like a decreasing, overall decreasing trend. So basically, you know that it's going downwards. And given that the initial velocity is 25 meters per second, you know that when t equals 0, which is on the y-axis, it's 25. Going down, approaching near infinity, hence it's near 0. For question 4c, you know that there's a decreasing trend. Remember to write 25 here, and then you can just graph it out on your TI Inspire, as this question is also a calculator question. Now, let's move on to question 4D. Find how long it takes for the boat to travel 30 meters. This question, at first, I thought was like, oh, this is quite easy, but it can be pretty tricky. Now, distance means that we are looking for a displacement function, which is, we can also say, the original function of this equation. Not the velocity, but displacement. Hence, what we need to do is a big thing in this chapter, which is like integration. Hence, by integration, 100 plus 1 plus the negative 2 power negative 2 by 1, you get t plus 2 and then negative 100, because don't forget you also have a negative 1 coming out from here. And don't forget, students, to plus c whenever you're doing integration, as it signifies the constants without without any x or y unknown values. Now, by finding, because we have this unknown, we'll have to find a way to find this constants in order to find our equation. Hence, because we know that it's even near infinity, it's also nearing 0 instead of negative or what. Hence, we know that the function, the original displacement function, when it's equals to when the t value equals to 0, it's you can still have the same thing. So when you plus c and it equals 0, you get 50, negative 50 plus c. Hence, the function is at first, we can see that even with an unknown, the displacement function is c minus 50. Now, when we have the displacement function as c minus 20, and then we want to find the boat when it travels 30 meters, originally it's equals 30. But we now know, because there's a known, of course, so that's why we have this bracket here signifying the original value when it's equaling 0. So, by like simple addition, you get c minus 20. Hence, when you substitute the integrated function, which is like originally negative 100, which we did before, t plus 2 plus c, equals to c minus 20 instead of 30. This is a very common mistake people make. People think, oh, this is such a straightforward question. But people usually tend to forget about the c. Okay, now let's continue. Because we already have like a c here and here, it's easy. We can just cancel it out. Hence, you get 20t equals 60. T equals 3 seconds. Let's move on to E then. Find the acceleration of the boat at any time t. Acceleration is the second derivative of the displacement function, which is the derivation of the velocity function. Hence, by deriving the original function, 100 over t plus 2 squared by deriving this function, you add one value here, you times it by negative 2, 100, hence you get negative 200 over t plus 2 cubed.